Are we live?
Yeah, I guess so. Hello, guys.
Yeah,
I
we
hope
are
you
live.
see well. My name is Mark, and Narek is today with me, or I'm with Narek, rather, like this. As I told you yesterday, Narek is one of the greatest developers in FunC, and he's going to. I will actually be with him as well, but we are going to overview the first contract. We'll also present a few facts about the FunC that it's important to know before you start developing. And I guess let's, yeah, Narek, you can say a few greetings.
Yeah, hi guys. So as Mark said already, my name is Narek, and I'm the head of TypeScript. My team is building a tooling for Ton developers. So today we'll be talking about how to write your first smart contract on Ton, and we will not do live coding because it would be too long, I guess, and we will be overviewing a written one. So let's start with a small theory part. 1 second, I'll share my screen. Yeah. So, so your first smart contract on Ton. Well, I guess most of the audience is familiar with the concept of smart contracts and had some experience writing them for EVM-based networks. And we will start by covering what's the main difference between the EVM and Ton. Well, first of all, contracts in Ton are interacting by sending messages to each other. They are not really calling each other's methods. They are sending messages. And this means that calls, they are not actually calls, they are just messages, and it's an asynchronous process. This means that it's not atomic, so you can't rely, you can't really like send messages from one contract to another and expect that it would be done atomically in one transaction. It would be split into several transactions. And also, one of the key differences is that your smart contract can't really run getter methods on other smart contracts. But you can like overpass it if another smart contract supports some message, uh, and well, your smart contract can send a message asking some information from other smart contract, and that other smart contract can send the message back to your smart contract with that information if it supports it. Also, contracts on Ton has to pay rent for its storage. This means that developers should take care of it. And also, in Ton, everything is stored in so-called cells. So cells, what is cells? Cell is this data structure which contains up to 1022 bits of data. It's not bytes, it's bits, and up to 4 references to other cells. This means that you can do basically any data structure like trees or something like that, but all of that data should be stored in cells. Like, and when I say that everything is stored in cell, it's actually everything. Like basically the whole state of the blockchain could be represented by a cell. The contract is a cell. The code that is compiled from that is got compiled from FunC is also a cell. The data of the smart contract is also stored in the cells. And also there is this thing called bulk, which is a bag of cells. It's the binary representation of a cell. So let's move on to TVM data types. These are the main data types. It's quite simple. We have integers, we have cells itself, we have slices, which is it's basically a slice of a cell. Since cells are they are immutable, you can't really start reading it from from in the middle. You should like do it sequentially. You you open it for reading by converting cell to a slice, and you read all of the values one by one. And there is a builder which builds the cells, and it works the same way as a slice. You create a builder and write all the values one by one. And there is a tuples, which is actually a collection of any of these types. And there is one more which we didn't mention because it's too, I guess, too low level, which is a continuation. Continuation is basically inside the TVM, it's a chunk of code that you can execute. But we don't need this in this example. So messages. Basically, there is two types of messages in Ton, external and internal messages. Uh, Internal messages are pretty simple. It's messages from one contract to another contract, and they also carry some amount of coins with it. And usually, contract uses those coins to pay for the gas. And there is external messages. External messages are quite interesting. They are used to get some information from outside of the blockchain. So you can send external message to a contract just by like calling some API. And external messages doesn't carry any value. So smart contract should there is some amount of free gas for smart contract to decide whether or not he will accept this message, and smart contract should pay from its own money to handle this message. Basically, the most simple example of using external messages is wallet smart contracts. So in Ton, there is no difference between accounts or smart contracts. Everything is a smart contract, and your wallet is actually a smart contract too. And it works like it accepts external message that is signed by your private key. And if the sign is correct, it accepts it and do what you want to do. Yeah, basically that's it on the theory. We will straight jump to the code, and we're gonna overview a smart contract that splits coins. Let's jump in. So we have this project set up. We used Tom Create, which Mark mentioned yesterday. And basically, this is the source of the contract. And we'll go line by line, basically. So here we are declaring the variables. We choose to do it globally. Basically, it's a good practice to do it in Ton because you don't really want to pass around many variables to the functions. So we just move them to the globals. So this one is responsible for the owner of smart contract. This is the processing price, which means that basically how our smart contract should behave. Well, we want to create a smart contract that when some message with some value comes into this smart contract, it should split it to the shareholders. And since the process of processing this message costs some money because of the gas, because of the fees for sending the messages, we are storing the processing price, and we will deduct it from the amount of money that we get. Also, there is the shares. It's a cell. But actually it's a dictionary. So note that when I showed the types of the TVM, there is no dictionaries actually, because the dictionary is basically also a cell. It's specially serialized cells, and we have like special methods to work with the dictionaries. And also there is a seed. As Mark mentioned yesterday, smart contracts address they are deterministically calculated by the code of the smart contract and the initial data of it. This means that if we have like the same shares and like the same processing price and the same owner, we can't deploy two smart contracts like that because the address will be the same. And this is why we introduced this seed variable, which we can like change a little bit, and the address will be other. So here's the load data function. Basically, in terms of syntax, FunC is pretty simple. So here is like simple function declaration. It's a load data. It's impure. This means that we are telling the compiler that um, this has something to do with the data of smart contracts, or so that compiler would not like raise this function for the optimization. So here we are calling getData method, which returns the root cell of data of the smart contract, and we're calling begin parse, which transforms it to the cell to the slice, sorry, and we can read from it, and we are filling the global variables. We just like do load message address, load coins, load dict, and load uint. Not that we specify how amount of bits we are reading for the integer. You can read like even 1 bit, and it would be like a boolean. Yeah. Also, TVM doesn't have a separate boolean type. It's just like integer. 0, 0, 1 is considered to be true, and 0 is false. And here is the receive internal function. It's basically it's the standard handler for receiving internal messages, and Ton would pass to that function the balance of the smart contract after receiving the message, the message value itself in nanotons, full message, which is a cell. Basically, since everything in Ton is cell, so message is also a cell, and we in the documentation you can find the layout of the message in special language for writing the layouts for the cells called TLB. And slice message body, it's the message full contains like full information about the message, like flags or stuff like that, and body is like just the body that other smart contracts send with the message. And so here we are doing some interesting stuff actually. So messages in Ton could be bounced, so-called bounce mechanics. Bounce is when you send some message to a smart contract and there is some exception in that smart contract, this message, or like there is some other problem, like you don't have the amount of money to pay the gas or something like that, this message got bounced back to your smart contract. And when it bounces back, there is a special flag for it, and you can check it. And we are doing it right here. We are reading flags. It's 4-bit length, and we are checking the rightmost bit. If it's set, that this means that this is a bounced message, and we in this case we don't really need to handle those messages because we don't really call other smart contracts. We just send in the value.
Don't be scared, guys. Don't be scared of this part. It's something that sometimes scares people, but you can actually, at the moment you will need this, you can find the definition of each flag that can be there. And for now, it's important just to know that we don't want, if you don't write any special logic for the bounced messages, you just always keep this if at the beginning there, right after you read the flags, and you always have to read the flags, even if you don't do anything with it. This is important that you have to read them through and cut out the bounced messages.
Yep. Yeah, it might look like a magic, but it's not. So here we are reading the sender address, and we know that after the flags is coming the sender address because we like have the TLB schema of the message, and we are loading the data, and so load data populates the variables, global ones. And here is some admin methods. So it's a simple check that the sender is the owner and that the body of the message is empty. Not empty, sorry, because if the body of the message is empty, it's considered to be a simple money transfer. And in Ton, basically, there is this convention that if it's not simple money transfer, first 32 bits is the operation code. So we read the first 32 bits and we check it. We compare it with the strings, and it's not actually a string. Note that there is a C at the end. This means that FunC compiler actually does CRC32 on this string and compares it to that number. So so here is a simple method that allows us to like change the data of the smart contract in future if we want so. And here is an interesting thing. We can Ton actually allows you to change the code of smart contract after deploying it, which you can't do really on Ethereum-based networks, but in Ton you can do that. And there is a simple method for that just accepts coins. Why do we need that? Well, as I mentioned, in Ton, smart contracts should pay like a rent fee for the storage. And this means that, for example, if your smart contract was like nobody used it or for a while, and you like want to put some coins to keep it alive, you can do that.
Narek, so sorry for interrupting. Can I ask you a question? Because I just checked the chat of the Hackathon group, and there was a question like exactly about what you just described. So
Yeah.
if the contract is not touched, let's say there was no messages sent for a month or for half a year or for a year, how this price of the rent is going to be taken after, and how much it would be, like what kind of numbers approximately were you talking about?
Well, this is how it works. When there is an incoming message to the smart contract, so there is several phases of the transaction. There is like storage fee phase. It comes, I think, the first, and basically it calculates when was the previous message handled by this smart contract. It calculates the difference in time. Multiplies it by the like price of the storage, multiplies it by the amount of bits your smart contract occupies in the blockchain, and deducts this from the balance of your smart contract, or from the balance of your smart contract. And it's quite cheap actually. We calculate it, and well, it depends on the current config of the network, but it's the current numbers is like if you want to store like 1 megabyte of data on blockchain, it costs something like 3 tons for a year. So it's quite cheap. But it's a thing that developers should think about, because it's a good practice to took some amount of well, it's a good practice to have some amount of tons at the balance of smart contract.
So you actually do like tax management, so you're taxing your
like that.
your users in a way.
Yeah. So let's move on. So basically here we are saying that we're gonna split all of the balance of the smart contracts minus the processing price. And if it's lower than 0, we're not gonna do anything. We will just accept those coins. And if there is like several, so if there is if we receive several times a very small amount of money of tokens, we will just accept them. And when it's accumulated to the point that we can really send it, we will send it. And here's the interesting part. We're just so it's a loop, and we're just iterating through the dict. This means that, well, basically dicts are in turn, to work with them, you should know the k length. All of the functions that work with the dicts start with the k length and with the dict itself. So in this case, this operation just accepts the dict, k length, and the index, and searches for the next value with greater index. So we start with 0, 1, which means that we will receive the 0th record, the first, and go on. So we iterate through it, and the values in the dict are slices, and we decided that in that slices, so the record in the dict would contain all of the information about the share. So it's the address of the shareholder, it's the factor, the base, and the comment. Note that it's a load ref, which means that there is no strings in tone actually. Load ref just reads reference to other cells. There is up to 4 references to other cells, might be in one cell. We calculate the value by moldiv, and we send the message. Actually, I wrote this helper function which sends a comment message, and we can jump to it. And again, it might look like magic, but it's not. All of these, well, it follows the layout of a standard message described in TLB schema. So it's like some flags, address of the recipient, like amount of coins, more flags. This means that it's the operation code, and if the operation code is 0, it's considered to be a comment message, and we store the comment itself. And also we send the message, and there is several modes for sending the message. There's the default, there is the destroy of 0, so you can manage your money. For example, you can for example, one of the most used is carry memory value. This means that it's like, let's say you are calling some smart contracts and sending 1 tone with your message. If smart contracts smart contracts does some calculation or stuff like that and sends the response to you, and if it does with mod 64, it will return all of your money that was not used to pay the gas prices. It's quite useful. So basically, this is the whole code for the smart contract to work, but it's nice practice to have getter methods. In opposite to Ethereum, as I told you earlier, get methods couldn't be called from other smart contracts. They are basically they are useful to interact with the smart contract off chain. So they are pretty simple.
Read-only. Yeah, that's the only way to get a data from inside of the memory of contract.
Well, not the only way. You can actually call some API and get the data cell itself, and if you know the layout of the specific, if you know the layout of the data cell of the specific smart contract, you can decode it. But it's quite convenient because, for example, if you're writing, I don't know, NFT smart contract, a custom one, none of the marketplaces know the layout of your data cells, so so you should define getter methods. So getter methods are pretty simple. It's just a function with method ID identifier, and here we are loading the data and returning the processing price. And here is the same for the owner, and here is actually we are returning the whole data cell of the smart contract. and I'll show you how we'll use that. And basically, this is the smart contract. And now we will move on to some TypeScript code to interact with it.
Narek, sorry. Okay. Is it okay for you if I interrupt you sometimes? Because I read the questions from the guys
yeah,
in chat.
yeah, okay.
And you can have a little rest, so I can answer some of these questions, and we can then answer together as well. So,
Yeah, okay.
one of the questions was, what happens if we don't mention the impure keyword function? So, if we don't mention this modifier, and I think I can take this one on. So, basically, there is a few kinds of modifiers, and as Narek said, impure means that it actually affects the state of the contract. So, if there is no modifier impure and the result of this function is not used anywhere, the compiler will simply get rid of this function because it's not. We say it's not affecting the state, and it's the results of this function. This function is never called, so it's like optimizing it and just cutting it out, and that's exactly what's going to happen. It's just an answer to one of the questions. And the second question, how we can debug on tone contract. So what are some methodics to debug this? But I think you will get closer to this on TypeScript, right?
Yeah, we will cover that.
And
So
there's also greetings from DevDAO, mysterious DevDAO guys. No one knows who they are, but they're doing crazy stuff.
hi guys. So yeah, this is the whole code of the smart contract. It's quite simple. I mean, the language itself is quite simple, but there is some parts of you should know how the tone works, and you can find that in the documentation. Yeah, let's move on to the TypeScript code. So first of all, in order to interact with the smart contracts, you should write the wrapper. And basically you start by like it's convenient to start by like describing the data of your smart contract, and in this case it's basically the same that we see here. This is the owner, this is the processing price, this is the shares, the address factor based on comment, and this is the seed. And after that you need to write methods that encode your like config of the smart contract to the cell. And here's how it looked like. So here we are creating the shares should be a dict, and in order to manipulate with dicts, we have this thing called dictionary value. You just specify two functions, one which serializes the value for that dict, and one that parses it. And we use basically this tone library uses the same concepts that FunC does, like the builder, cell, slice, etc. So here we are. It's basically the same layout that contract uses. So if we take a look at here we got the share from the dict, and we assume that the address comes first. Factor is an uint with 16 bits. The base is same, and the comment is some string in a reference cell. And here is the same. The address comes first, factor base, and string ref. Same for the pass, but the opposite. We just read it. And when we are trying to serialize the config for the smart contract, we first like serialize the shares, and we should specify the bits k length of the dictionary. Here is just simple code that checks that total sum is 100%, and we write the shares. And here's a simple like example of how to build cells in TypeScript. You just like begin cell, basically all of the same API that FunC has, like begin cell, end cell, store address, store comments, etc. And once we have that, we write this class that implements standard contract interface. And yeah, 1 second. So you can create it from address if it's like a real one deployed in network, or if it's deployed in your test environment, and you can create it from config. So it accepts the config, converts it to a cell with our function. Also, it accepts the code and creates a new one with computing the address. We also write some functions that like send the right messages to work with the smart contract. For example, the send update data. This sends the internal message to that smart contract with the body operation update data. So note that, as I mentioned, the first 32 bits considered to be the operation code, and we should do that, just that. We create a cell, store the first 32 bits as a CRC2 or 32 of update data. And we store the new data in a reference. And if we go back to the smart contract, we can check that it assumes that if the operation is update data, it searches for the new data in a reference. Basically, the same for the update code, the same for the top up. And also note that we specify the amount of coins we send with it. Basically you can, you just can like write some tests and check out how amount of gas uses your smart contract and find the right amount you want to send with it. But as I mentioned before, it's a good practice to return the money that is not used for the gas using the 64 flag, so that you can like even send 10 coins and most of it will be returned back. And here is how to write getters. It's that simple. You just like call it by the name, and it returns a stack, and you can read like values from that stack, like read big number, read address, stuff like that. And here is interesting one. As I mentioned, we had this getter method that returns all of the data of the smart contract. Here it is. And I wanted to show you that we can do that. Actually, we return all of the data of the smart contract, and we can decode it. We can decode it just like that, because we wrote, since we know the layout of the config of the smart contract, we wrote like the opposite function to the config to cell, which works like this. That simple. We just convert, just like in FunC, we just convert this cell to a slice, read the values, load the dict, and that's it. And there is a helper function that like returns the balance of the smart contract. So that's it for the wrapper. It's really simple, and basically after you've done that, you can like write tests on it, and it's simple too, actually. So we have this tool called Sandbox, which allows you to basically it emulates the whole blockchain locally without running any nodes or stuff like that. It does that in JavaScript. We have compiled version. We have like C++ library that handles transactions just like the network does, and we compile it to WebAssembly. So Sandbox really emulates how the blockchain works. And here is how to deal with it. Well, you create an instance of blockchain, and this test is checking out that our contract is getting deployed. And actually, there is an interesting thing. Actually, in Tone, there is no such thing as a deploy, actually, because when you are trying to, well, basically, when you are sending a message, message can carry with it like a body, which is a cell, and it also can carry a state in it, which is code and initial data. And if you send this kind of message that contains state in it, and the contract is not yet active, it's not initialized yet, then it if the hash of the state in it is the same as the address to which you are sending this message, this contract gonna be initialized. And if not, it's just ignores, like it handles the message, but doesn't redeploy it. So so this means that in order to deploy, no, not like that. This means that, for example, if we deploy our distributor contract, it gets deployed and instantly accepts this deploy message. This means that when we deploy this smart contract, we will send some amount of money with this message, and distributor will instantly split the amount of money that he got from the deployment message. So in this case, we are like opening this contract, we're creating it from the config, we fill in the parameters, we create treasury, which is like a simple wallet with a big amount of money, and we like send deploy. Send deploy is pretty simple. It just sends any message. As I mentioned before, so tone library will actually check if the contract is not initialized yet. It will send state in it with this message. So we shouldn't care about that. So yeah, 1 second. Where's the test? Yeah, so we send deploy, we send this amount of tokens with it, and we check that there was a transaction from the deployer to the distributor address, and it was a deploy one, and then we call a get method on that smart contract and check that the owner is the same. It's that simple to write tests, and this is much more interesting example of test. We are checking that it distributes the coins according to shares. Here we are like creating a treasury, the owner. We are creating contract, and we are specifying that processing fee is this amount of coins. We are setting the owner, and we are specifying the shares basically. We say that the first half goes to this random address, and the second half goes to this random address, and the distributor should send these halves with these comments. We deploy the smart contract. We create another treasury and send 1 ton coin from that wallet to the distributor. And then we check that in the result, we have a transaction from the distributor to the first shareholder, to the second shareholder, and we check that there was some money transferred. Note that we are sending one ton coin, and we are checking that it's the half of 1 ton coin minus some amount of ton coins, because some amount of ton coins are gonna be spent to like messaging, transfer and fees, and it actually depends on the current configuration of the network, and also we check that the body is a comment with this text. Same for the second half. And this is a sample test for data update. We just like also creating a distributor smart contract. and we are sending like asking it to set the data to an empty cell, and then we can like this is what I mentioned before. You can get whole of the state of the smart contract. This is how can we do that? And basically the state of a smart contract is like it can be uninitialized, active, or frozen. And if it's active, it's a state in it. So it has like the code, the data, libraries, which we were not going to cover today, and like some special things. But basically, yeah, we can like get the whole cell of the data, and here we are checking that it's now an empty one. Same for the update, same for the top ups, nothing interesting here. And I guess we can now show how to deploy it. We have this simple script. Basically, you can write user-defined scripts, and it's just a TS file with which experts run function, and basically Blueprint will execute this file and pass like this provider thing to it, which is useful to deploy, to interact with this smart contract, to do all of kind of things. And basically we are creating a distributor smart contract instance that owner is me. It's like my wallet address, and shareholders are also me. It's gonna just like split any amount of money to two messages that are gonna be sent to me. We compile the code, and in order to compile, you just specify this .compile TS function and export compilation configuration. You just specify all of the sources and stuff like that. You can find that in the documentation, and we are just deploying it. Then we are opening that contract, and we can like get the address of it, or like call some get methods and stuff like that. And I guess we can do that. I'll just change the seed because I did that already. And
yeah, while you're preparing it, I will just note that as I was showing yesterday, this code, like this code that we overview today, it cannot be generated with npm create ton, but npm create ton has other templates that you really want to go into, and if you want a lot of these files that you see, they will generate it for you by template, and it's a good practice to go and see other developers' tests, and that's one of the fastest way to learn, and of course the FunC code as well. But just like I said, you can generate most of this code from template by npm create ton, and as you can see now, we are still using this blueprint. Like Narek is going to continue using blueprint, that you have a lot of scripts already ready for you out of the box.
Yep. Yeah, so in order to run like user-defined scripts, you just do yarn or npx or npm blueprint run, and it's like you choose the script. We have single one. We choose the deploy distributor script. We choose the network. We choose like the wallet the method we are going to use. So I choose the ton-compatible wallets like Tonkeeper. And since I already connected it yesterday, it just shows transaction on my phone already. And here is it. I confirm it. And it's sent, and it's checking that the deployment is okay. And when the deployment is okay, it will like here it will print the address of the resulting smart contract. Yep, here is it. And we can view it in some Explorer. I prefer the Tone Whales one because it's quite convenient for developers. Yep, here it is. And so, as I mentioned before, since there is no difference between like the deploy or any other message, so it got the message with the code and the initial data, and it split it it handled it just like any other message, and here it is. So it split it in two halves, and we can open more information and check out that the incoming message contained nobody, uh, just an empty cell, but it had like state in it, the code and the data. This is like the binary representation of cells. And there was like two outgoing messages from this smart contract after the execution, both to the same address. And basically that's it. And here is the storage phase. You can check that how amount of coins were collected for the storage. Here is the credit phase. But basically the credit phase means that well, basically your smart contracts can decide whether or not to use them. What money should your smart contract use to pay the gas price? Basically, it can use either the money that came from the message itself, and it's the default way, or the money that the smart contract has. Here's the compute phase. It's just we can check that amount of gas used, the fees, and there is an action phase. In action phase, well, basically when basically in compute phase, TVM gets activated. It computes the code of the smart contract. It executes it and generates so-called action list. So in action, so when we are calling this function, one second. So when we are calling this function send raw message, it actually doesn't send it right away. It just records it to the action list. An action list is just a linked list of actions. And in the compute phase is where the action list gets executed. So it's just checks the messages and sends it. Well, basically that's it. I guess we can move to the questions part.
Yeah, we have kind of, as now the contract is on chain and we played with it, I can ask some questions about the code, and some of them I will address by myself. So for
Yeah.
example, I think we still didn't get to the debugging part. I mean, like if you can debug from inside of the FunC, what are the methods to call to get some like data at the middle of the like cycle?
Well, basically, one of the ways to debug is to call the getters to check that the data is okay, and the other one is there is some debug primitives like dump, which basically dumps strings or numbers. Also, there is dump stack, which dumps TVM is a stack-based machine, so we can dump the stack current one. And logs are actually not displayed by default, but you can, yeah, one second, you can enable them in Sandbox. You can enable them. Well, actually, I'm using quite old enough version of the Sandbox here, and in the current version of Sandbox, we added a method to the blockchain class that sets the verbosity for the whole blockchain. But in this case, we can do it like this. We just get the contract state from the blockchain. Press, and we can do like contracts. verbosity to like full. And after that, it will like print all of the information that you need. It will print like the operation. It's like it will be basically step-by-step logs of the execution of your smart contracts, including like these debug operations like dump stack or dump.
Okay, cool, thank you. And there's another question about verification on testnet. I just outreached to the guys who spin up the verifier service on mainnet, and they said that for now it's not available, but they have this in plans to actually run the verifier on testnet as well.
Mm-hmm.
Okay, and there is some question on the reverse engineering of the source code. So let's say we have the code inside of the cell, and if the let's say if the code is not open sourced and verified, is it possible in any way to reverse engineer and hack the contract?
Well, basically, it's like the same as the other languages, like C. You can't really like reverse engine, like you can't compile it back to FunC, but you can check out the result in assembly code. And yeah, 1 second, we can do it right here. So come on, load faster. So basically, we have this disassembler, which takes the cell of the code and disassembles it to like TVM assembly. And here, like Explorer says that it's unknown contract, and if we jump to that, it will show us actually the raw data cell of this contract, raw code cell, and the disassembled code. So here is the disassembled code for our smart contract. Basically, if you're really gonna need to like reverse engineer it, you can do that, but it's not quite easy.
And it's out of the scope of FunC for sure. It would be more of an assembly history, right? Or
Yeah, it's just much lower level.
Okay, so I will go through some other questions. What is the difference between this tilde and dot when we call some methods or functions?
Oh, it's a good question. Actually, so if we jump to the declaration of those functions, for example, like load message address, basically it looks like this. It accepts some argument, which is a slice, from which it loads this address. But note that we are not passing it actually. This means that actually there is two ways to call this function. We can do it like this, or we can do it like this. And well, basically this tilde thing is like a simplification. This means that we are gonna mutate the DS variable, and it's just more convenient to do it like this because it's just simpler to look at it. And the dot is actually kind of the same. The dot means that this method is not mutating, and it works like the same. You're not just so get data is a cell, and begin parse accepts a cell. And if we do it by the dot notation, the FunC compiler will pass the cell for us. It just like we just do it like this.
Mm-hmm. Okay, thank you very much. I believe this is one of the candidates for the award because
Yeah.
as yesterday we had chosen 3 questions that will get a reward from Ton Foundation, and you guys will be informed how to claim it. So there's a few questions that we are not going to answer, but I'm going to list them, and so the guys know that I saw them. So we are not going to go into the stages of development because I covered it yesterday. and I will do my best to have another Q&A session with more on the thinking like smart contract developer with Narek, because Narek can say a lot of things about that, but it's going to be outside of this scope of this stream because we don't have much time left. And also, we're not going to go into TLB schemas, and this is also going to be covered on some other sessions. And we unfortunately are not going to go with like update code examples, because each of these topics would require us to spend another 20-30 minutes on covering these topics. But stay tuned. Maybe, Narek, can I ask you to show the presentation again? Because there's a few important QR codes that we want to share with the guys.
Yeah.
So this is first of them. You guys should definitely scan the QR code if you want to stay tuned and join some Q&A sessions with Narek. I hope Narek will be kind enough to join some of the talks on Ton and Co. And another, can you please go one slide further? So Narek is also one of the mentors on the list. So you can submit a request explaining your project, and if we have enough time, you might even get a mentorship session from Narek. So that's another thing. And if you could please switch to the next slide. So this is a dev chat. So a lot of questions that can be answered like in text, you can ask in the dev chat, because pretty much every developer I know in Ton is part of this chat. And if you're kind enough and explain your question good, just drop it there in the chat, and you will get your answers quite fast. And the last QR code I want to share with you is this group that is dedicated to the Hack-a-TON DoraHacks. So you should join this group, and there you can find information about the offline events. You can find other guys who are also trying to participate. So to take the best out of the DoraHacks hackathon and to get onboarded into the Ton programming as fast as possible, you should basically scan all the 3 QR codes and go check it out. But I really want to encourage you to at least join one of these resources. So yeah, that's pretty much it, I guess. Narek, thank you very much for so detailed things you told me. And guys, like I really learned something new for myself. And so I'm very, very happy that I'm participating here with you. And guys, you can actually go into comments and write your thanks for Narek. Like this video, also very good to show your love. And yeah, we guys gonna see you tomorrow then.
Yeah, thank you, Mark.
All right.
Guys.
Ciao, ciao.